Welcome to Study Loop.
So we have a disk of charge that has a non-uniform charge density that looks like this. Big R is the radius of the disk. Little r measures my distance out to my source point. Y measures the distance up to the field point. And X is the hypotenuse of that triangle formed by R and Y. This is a 90-degree angle. Okay, so the voltage or the potential at A is going to be given by an integral. It's actually a double integral. We have a theta integral. We're basically going to be in polar coordinates here. So we get this volume element for that. And then we get our sigma of r divided by x squared with a factor of k for the Coulomb's law. Okay, that's an equal sign. So it turns out we can do the theta integral right away. So we'll write that as 2 pi. We get a k coming out, and then we have 0 to capital R of r dr. Then sigma of r is little a times r. And then the denominator, x squared, is y squared plus little r squared. So 2 pi ka integral 0 to capital R of little r squared d little r divided by y squared plus r squared. So as far as the integral is concerned, y is a constant. And so we can kind of treat it as such in doing this. We can look that integral up in a table of integrals. Okay, so when I look this up in a table of integrals, so there's two steps. First reduces the power here. So we get this is our first step, and then we can look this one up. And the second step, substitute in the limits, and this is what the answer looks like. And it actually does have the correct units, and so we're all good. Because we expect, in fact, that this should have units of meters, since we know A goes like charge over cubic meters. So our net electric field has to have a charge over square meters times K in order to have the right units. Excuse me, charge over has to have K times charge over meters. And A goes like 1 over meters squared. So we're okay. We could then plug in our numbers, but since it's a function of y, depends on how far away we are. Let's put in our actual numbers because we know what y is. So it's 2 pi times 9 times 10 to the 9th times a, which is 1.46 microcoulombs, so it's 1.46 millicoulombs rather. Times 10 to the minus 3. And then we're going to have R, which was 0.124 minus Y, which was 0.5 times the arctangent of 0.124 over 0.5. And that comes out to be, so when I plug all the numbers in, here they all are, I get 2.037 times 10 to the 5th volts as my answer.